Math Analyzers. Welcome to your Chapter 10, Lesson 8 notes, where we introduce the next three trig functions. There are 27 total trig functions. I am not going to introduce to you all 27, but I am going to give you the very cool reciprocals of sine, cosine, and tangent. So that's what we kind of want to look at today is, okay, sine of your angle is opposite over hypotenuse, right? Cosine of your angle in question is adjacent over hypotenuse. And tangent of your angle is opposite over adjacent. But what if I went backwards for each of these? If I flipped each of those fractions upside down, I have a whole new function that I'm looking at. And those, my friends, are called the cosecant, secant, and cotangent ratios. So just like you can take 2 and flip it upside down, and now you've got its reciprocal, 1/2, you can do that with trig functions. That means you can take sine and you can flip it upside down so that it's 1 over sine. Throw that sine over a 1, flip it upside down, and that's your reciprocal. And that itself is a trig function as well. That's your reciprocal. And that trig function that matches sine is what we call cosecant. And cosecant is abbreviated CSC. When you flip cosine over, make its reciprocal, you get secant. And that is abbreviated SEC, like second, like what would abbreviate second. And then when you flip tangent over and create its inverse or reciprocal ratio, you get cotangent, which is abbreviated COT. So what I like to say, right, is that each function has a co-friend. Sine has a cosecant friend. Cosine is the co-friend to secant. And tangent and cotangent are the co-friends. So those are the partnerships you want to think of. That means that cosecant is actually 1 over y. That means secant is 1 over x. And that means cotangent is x over y, which means it has the opposite asymptotes that tangent has when you go to graph it. What's cool about these? These are the opposite graphs of sine and cosine. So sine and cosine have the hills and valleys that keep going and going. Well, cosecant and secant, when we look at these tomorrow in function form, are just a hill, a valley, a hill, a valley, and tons of asymptotes in between. So it's pretty neat how they end up looking as a result. But really, what we're going to do with this is just note that a lot of things really don't change. Okay? We need to know these exist, but as long as we're able to work with sine, cosine, and tangent, working with cosecant, secant, and cotangent is going to be a breeze. Okay? Because in your unit circle, if sine and cosecant match up, then they will be exactly the same signs throughout the unit circle. Okay? So these guys, as long as you know what sine is in each of your quadrants of your unit circle, you're fine. Same with then cosine and secant and tangent and cotangent. So there's nothing really new there. You just got to know who matches up together. Okay? That's all you really need to know. If you want to know where all these things come from, that's these two circles, these two unit circles that I'm showing you, as to what each of these values is actually figured from. If you don't know this, fine. That's fine. That's not a big deal. Knowing this is not the end all be all. Being able to work with sine, cosine, and tangent is what we really need. And then understanding that there are inverse relationships that match up to cosecant, secant, and cotangent, respectively, is what we truly need to walk away knowing. Okay? That's honestly it. This stuff gets way deeper. And like I said, this is 6 out of 27 trig functions, trig ratios, I should say. So as long as you're good with that basic sine, cosine, tangent, all these other things can be figured out from that point. Okay? Like I said, the basic, oh, I thought we were talking about it tomorrow, but I guess we're talking about it today. The basic comparisons of the graph, right? Of your functions. If sine was the unwrapping of the unit circle at the y values around the unit circle, then cosecant is all its opposites, which means that anytime there's a hill for sine, there's a u for cosecant. Anytime there's a valley for sine, it's an inverse, an upside down u for cosecant. Opposite for cosine and secant. So notice these are essentially the same graph. You just watch for your asymptotes. The asymptotes on secant will be at the pi over 2's, so at 90 and 270. The asymptotes for cosecant will be at 0 and 180. And still every 180 degrees, that's where you'll see your asymptotes because they're inversed. So when they get inversed, there's going to be zeros in denominators. And we can't deal with a 0 in a denominator. You cannot divide by 0. That's not a thing that our operations can do. All right? So that also means that cotangent is just the inverse of tangent on the graph. So notice their asymptotes will also scooch over, right? So the red asymptotes are for cotangent. So those are going to now be at pi and 0 and pi and 2 pi. So now you're going to have those asymptotes starting at 0 every 180 degrees versus tangent, as we know, starts at 90 every 180 degrees. You get an asymptote. So it's just kind of those opposites. By the way, cotangent will have the same asymptotes as secant. I'm saying that wrong. As cosecant. And tangent will have the same asymptotes as secant. So those asymptotes match up. And again, if you're trying to look at all of them at the same time, you've got quite the graph. They did match them up color-wise, so you can see what everything looks like. It's quite the graph, and all we wanted to do was unwrap a unit circle. That was all we wanted to do. And here we are with all this inverse stuff, right? So what we're going to do in our homework is we're just going to find the values, the matching ratio values of cosecant, secant, and cotangent now that we know who they match up with inverse-wise. If you can figure out the sine ratio of a triangle, or if you're given the sine ratio of a triangle, you can find all the rest of the ratios. And same with any one ratio. If you're given that ratio's value, knowing how these match up, you can figure out any other missing ratio. That's the plan. That's how we're going to look at these. Will I make you graph those functions? No. Matching them up? Yes, we will match them up. But that's about it, and you can use your notes to do it. Okay? So I'll see you guys soon for those. Have fun! More trig functions. Really wanting that stress relief now, aren't you? Bye, guys.